So, Canada Deuterium Uranium Reactor Candu. This is a reactor which is used for high power productions in our world. Mostly these generators is used. This generating type is used. Here we are having a structure of an HP turbine, LP turbine, generator, heavy water circulating pump, pressurized. Why we are using heavy water circulating pump? Because it's having a lot of energy to save the water to be steam. So a basic design difference between Candu heavy water reactor and the light water reactor is that the latter same water reserves as both moderator and coolant, whereas in Candu reactor moderator and the coolant are kept separate. Consequently, unlike the pressure vessel of a LWR and the Candu reactor vessel, which contains the relatively cool heavy water moderator, does not have to withstand a high pressure. Only the heavy water coolant circuit has been pressurized to inhibit boiling the core, the Candu reactor vessel and the core. The arrangements of the different components type reactor is shown in the figure which in the first slide. The reactor vessel is steel cylinder with a horizontal axis. Length and diameter of a typical cylinder are 6 meters and 8 meters respectively. The vessel is penetrated by some 380 horizontal channels called pressure tubes because they are designed to withstand a high temperature. The fuel in the Candu reactor is normal, that is unrich. Uranium oxide as small as cylindrical pellets. The pellets are packed in the corrosion resistance zirconium alloy, nearly 0.5 meter long and 1.3 centimeter diameter to form a fuel rod. The relative short rods are combined in bundles of 37 rods and 12 bundles are placed end to end in each pressure tube. Total mass of the fuel in the core about 97,000 kilograms. Control and protection system has this. It has several types of vertical control elements. They includes a number of strong neutron absorb rods and cadmium, which are used mainly for the reactor shutdown and startup. In addition, there is other less shortly absorbing rods to control power variation heat distribution throughout the core. In an emergency situation, the shunt rods would immediately drop into the core, followed if necessary by the injection of a gadolinium nitrate solution into a moderator. So, steam system, the respective end of the pressure tubes all connected to inlet and outlet headers. The high temperature of the coolant leaving the reactor passes out the outlet headers to a steam generator of a conventional inverted U-tube and is then pumped back to the reactor by the weight of the inlet header. The steam is generated at a temperature of about 265 degrees centigrade. There are two coolant outlets headers, one at each end, and the reactor vessel corresponding to the opposite direction of the coolant flow through the core. Each inlet header is connected to the separate steam generator and pumps. Single pressure of the types used in the pressurized water reactor maintains an essentially constant cooling pressure. Advantage: enriched fuel is not required. The reactor vessel does not have to withstand a high pressure as vessel of PWR and BWR. Only the heavy water coolant circuit has to pressurize to inhibit boiling in the reactor core. Therefore, the cost of the vessel is less. The moderator can be kept at a low temperature, which increases its effectiveness in slowing down neutrons. Heavy water is used as a moderator, which has higher multiple factors and low fuel consumption. Site consumption record less as compared with the PWR and BWR. Disadvantages: heavy water is very costly, leakage problems, very high standard of a design, manufacture and maintenance are needed. The reactor size is extremely large as power density is low as compared to the PWR and BWR.